Welcome to another GCBASIC demonstration suite. This is a complete new set of videos for the 16F chip family. I'm going to call them legacy. I'll explain why they're legacy later on. This is part one, turning on an LED using GCBASIC. So, first of all, this is January 2025. I've done videos like this in the past for these legacy chips, and a legacy chip is something that is rather old. It doesn't have certain characteristics, something in particular called PPS. So these are for the older chips, and this represents a sort of reanalysis of what we've done in the past, but just to make sure that people who look at the videos and they look for the last set, which is for a Q20, which is a new chip, this old legacy stuff is somewhat different and is simpler to use. They are more expensive as Microchip put the prices up of these old chips, but I just need to have a set of videos that really sort of baselines out these legacy chips. 16F could be a 12F as well, actually, or a 10F, but I'm going to use a 16F. So, like and subscribe the video. Subscribe to the channel is absolutely mandated, and let the video run all the way through, please. Okay, so what's a 16F? Well, it has digital analog peripherals. We're going to see that. A 16F could have an 8-bit or 10-bit ADC. Some of them might even have a 12-bit ADC, but I don't think that I'm going to be showing a 12-bit. They have multiple communication interfaces, serial I2C, SPI, pulse width modulation, absolutely plethora of stuff. And they come in 8 bits, 8 pin, 14, 18 pin, 20, many different packages, and they've been around since in the early days of microchip. So this is worthwhile seeing this set of videos because it takes you through the basics. So what we're going to do is just get the hardware operational and make the board work. And just make some LEDs turn on. Very simple because it's all about the tool chain itself as well. And the tool chain is what the compiler is. So GCBASIC is a compiler. It's what's called open source. That means that it's published up on the internet. You can download the source and wade through it and make your own changes. It's the same program for microchip PICs, AVRs, also now from microchip, but they used to be from Atmel, and LGT from China. And we're adding in more microcontrollers this year. Now, it's always supported the 16F chip family. Um, as I've said, this is focusing on what one would call, in quotes, a legacy chip. So what we're going to do is we're just going to review getting the software installed, making sure your programmer works, and then test that you've actually got it attached. Because if you don't do those things, it's a bit hard to understand what's going on. So I'm going to have 4 LEDs connected to something and through some resistors. And it's going to be great because we're just going to turn on these particular bits. They're called bits. RB0, RB1 on the right hand side of that diagram through to RB3. They're called bits. And when you turn a bit on, the LED will come on as well because the electricity goes through the LED through to the ground. And J6 on my board is connected, therefore we'll get a signal. We'll get the LED come on. So what am I using? I'm using this. I got sent one of these. Let's have a look at it. Let's have a look at that board. Look. Let's go to desk cam. Look at that. It's great. It's an old board, circa 2010. That's the date of it. Got an LCD, got a chip installed, like a big chip installed, look, because I'm going to do lots with it. It's got a prototyping area here. But this is it. I've got it connected up, and it says on here, and we're not going to do this LCD stuff to start with because that's more complex, but this board has got all manner of equipment on it, temperature sensors, memory, sound, just fantastic board. And I got, this was sent, I think this cost the guy 16, let me have a look at the bottom of it, 16 British pounds, which is nothing. So do not think that these old boards are worthless. These are worth a lot of money, and they're great boards to get off of eBay and other reselling platforms. So what have I got on here? I can put in an 18, 28, 40 pin microcontroller. It's got onboard regulators. It's got at number 3, it's got a RS232 serial connection. We'll hook into that. We won't need to be using an axle port, but we're going to hook into that. We can do programming and debugging. We're just going to do programming through using a PIC16xxx. You can use a PIC16xxx. At number 5, where's number 6? Number 6, it's got a potentiometer to control the LCD. It's got some buttons down the bottom here at number 7. Number 8, it's got power indicator LED and 4 LEDs at number 9, which is at the top here. At the top. Let me just bring in my pen. Here. Number 9's up the top here. So that's what we're going to be doing today, turning that on and off, okay? Which is great. Let me just erase that. Number 10, we've got oscillators, all manner of oscillators that you can put on it. You've got, as I said, at number 11, EEPROM. Number 12, LCD. Sound, I mentioned that. Prototype area, this huge prototype area here. And an expansion of what's called a pigtail, but it's actually useful for other things. And we're going to actually use that to hook into that GLCDs and other types of devices. Obviously, at number 16, where's 16 on there? Oh, it says here 16 MCUs. Actual fact, I think that's a temperature sensor. No, that's 17. Well, that's the board I'm using. You can have another look at it. So here it is. That's the board. £16. You can't go wrong with that. Oh, it's got a 31K. That's the oscillator there. That is definitely the temperature sensor. So absolutely temperature sensor. And 17 was definitely missing off that diagram. I'll go back to that. 17 was actually this area here. That's 17 there. But we'll leave it as written. So what are we going to do? We've got a prototype board, and you can build your own prototype board. All you're going to do is hook up port B, use this example, and you'll enjoy yourself. Make sure you put the resistors in there. I'm going to power this at 5 volts. I have a programmer attached, and as I said, I've got these LEDs. So let's have a look at what I've got in terms of a programmer, okay? Well, what I've got attached, I'll just grab another one from the top here. I've got one of these, look, there. It's a PIC kit. Now, I've got oodles of them. Look. Someone said to me the other day, I've never seen so many PIC kits, but it's obvious, I've got this, and they will all work. PIC kit 2, PIC kit 3, PIC kit 4 will work. This is the fastest, okay? This is slower. PIC kit 4, PIC kit 5 works fine. They all work, okay? Now, where is it connected to? I'm just going to disconnect it. Look, it's connected here through this one, through this connector here. And so it's very simple. I'm just going to plug that in, and voila, I have a connection to a programmer. I have at the top here some chips here. Why have I got some chips here? Just so I can tilt the board up. I've got power here, and then I'm just tilting the board up so you can just see that LED, LCD this morning. Okay, how does that all work? Oh, well, I've got some software installed. Let me just show my desktop. I have got installed on my desktop, I've installed some software for driving that PIC-Kit2 programmer. Now, I happen to sell that software, so please go buy it, PIC-Kit Plus. I'm going to press the Windows key, and I'm going to type in PIC-Kit. And PIC-Kit2 Plus comes up. Look, there are alternatives out there, but we support ours, okay, properly. Now, I'm going to zoom in on my screen. Well, I thought I was zooming in on it. Oh, that's interesting. Oh, I can see what happened here. Here we go. I'm just going to, there we go. I've zoomed in on my screens, and I'll do that quite a bit so you can see things. And if you look at the screen here at the top, it says there's a 16F1937. And that's the chip I have chosen. I've just taken one at random, not a big memory chip, but in here I can see it's connected. And if it wasn't connected, if I unplug it from the desk, so I'll go into this mode, I've just unplugged it, look, okay? I've unplugged it. And then back into that software. If I then go tools, if I'm on the right screen, tools, and I try to communicate, it won't find anything because I've disconnected it. So if it doesn't find it, then it says unsupported part. That's because it's not connected. I reconnect it. I will reconnect it. I'm not going to show you that. Tools, check communications, and I'm now talking to it. So this software, it comes in a number of elements, and one part of getting the programmer working, even before you start looking at GCBASIC, is making sure this bit works. It comes with a user interface like this, you can see on the screen, but also a command line utility, which I've also installed, which we will be using extensively because I don't use this interface. I use what's called the command line. So job one was actually get the program operational, and we have it operational. And if I read it, it will then read whatever was on that chip, and it will put it in the memory. We don't need to see much more than that because that just proves we have connectivity to that very fancy board, and that's important. So all I did was plug the chip in, plug in my PIC16xxxx, install my software, and voila, that has worked. Now, where do I get great GCBASIC from? Well, let me just bring up Chrome. You're probably going to see my house here in terms of, oh no, that's really good. Here we are in Chrome. I'm going to type in a search. I'm going to type in GCBASIC download. I'll zoom in for you. And there it is. It says download. You can get it from SourceForge, our website. You can get it from wherever you like. I don't care. If you just go for SourceForge, that's a great place to go. If I click on it, comes with the big download button there. Look, click on that, and then what it will do, it will install it for you. And I'll just drag that across, look, so you can see it. And now it's downloading the software. Download the software and install it to the default directories. The default directories. And then that will make it a lot easier as we go through this. Now, it will say to you when you're downloading that, it's thanking me, which is very nice. When you've successfully downloaded it, as I said, install it. It will ask you to migrate your PIC Plus installation. Do that because that will make it will just merge the two together and bring them into a consistent way so the tool works. So I am going to assume you've installed it successfully, and we'll see how it operates very shortly. So hardware, we've got it programmer attached. I've assumed that you've got some software. So let's look at what we're doing here. Okay, we're going to have a walk through 20 odd demonstrations in the set of videos, and we'll do very similar things. We'll have a brief introduction at the beginning, prerequisites, and then a bit of an explanation. Then we'll go do it. So what we're going to do is we're going to turn on some LEDs. It's called the direct addressing of a register through the bits. And what we're going to see is a couple of commands, or 4 commands, is how do we define a chip. I always recommend you type in option explicit, and I'll just keep reminding you of that. And that just makes sure you define all your variables. We're going to set the directions to an output for these LEDs, and then we're going to assign a value to the microcontroller bit, and the LEDs will come on. And we'll see that happen because we've got a camera. So what I'm going to do is I am just going to erase that chip. When I erase the chip, as you'll see here, that's not turned on. You might not be able to make this out very well. I'm going to pull that across and put that at an angle. I'm going to turn my camera. Oh, that's hard to do. And I'm going to zoom in because you might not be able to work this out, but that LED RB1 is turned on. It's on because that's pulled high by something. We're going to have to look at that to see if it works okay on the camera. But what we're going to do is turn these 4 LEDs on here. They're not on at the moment. This one is clearly pulled low by something because I can see a little glimmer. But just basically, I've erased the chip. Back to my desktop. So I've assumed that you've installed the software. you've accepted to keep the software in when you go through the installation process, and you end up in a editor. You might have closed that editor before you started this video, and that's my assumption. Press Window, type GCS as in GCStudio, and it will open it up. Now, you're in this screen here, and I will take you through this for this time, and that'll be the last time I do it. This is my, because I've been using this software, let me just take you through what you've got. Right, number one, you need to go and install these. I'll zoom in even further so you can see it. Look, install or update the demonstration services sources. Go do that. Go and install those because we're going to be using them. They have got the tutorials, the source code for what we're using. Okay, what you've got on the screen now is the version number of this. You can actually just walk through it. You've got all your old files that you've got open, you've been working on, a list of those on the left. Look, you've got an about button. The about button tells you about the compiler, etc. Might be useful if you're doing debugging. Okay, we might ask you for a version of that. You can open a project file, you can open a folder, create a new project, or continue without code, which will take you directly into the editor or the IDE. Down at the bottom here, donate please, because this does open source software is not free. And secondly, if you found a bug, report it. Now, I'm going to open a folder. And a folder has all the files in that we need. It's a very, very quick way of doing things. So if I open a folder, which folder is it? Where do we start? Well, it's actually, as you can see on the screen here at the moment, I'll zoom in so you can see it. It's actually in the what's called the vendor boards, microchip PIC2 plus board 2010. And that is because that's that board. You can use this code on any chip that's a legacy chip. It doesn't matter. I've just happened to use that board, so I put it in that folder. So I'm going to zoom out slightly, and I'm just going to say select folder. And that will open up what's called the IDE in full screen mode, which I will show you. And it might take you to something that looks like this. So if you want to see the files that are inside that folder, press Control B. It's the quickest. If I'm on the editor, Control B, and it lists all the files. Now you can't see them on the video. I will zoom in shortly. But that's Control B. It's the quickest way of seeing things. Control B. There's many different ways. You can say View, Explorer, Control Shift E. There's many different ways of getting up this screen. And in here, we've got all the demonstrations that we're going to walk through. I'll zoom in for you. Number 10, Hello World. And that's the one that we're going to be using. 2, blink, 3, 30, 40, 50. They have these odd numbers so that I can shove another one in. Look here, 100, 110. I realized I needed another one at 105, so I put one in at 105. It's an engineering approach to numbering things. So once you're in this screen here, you can, I'll just pull that across. Just tidy up my screen a little bit. Once you're in this editor, you can now double click Hello World, and we'll look at that. Control B, get rid of that list. Let's zoom in for you so you can see it. Great. So anything in green is comments, and you can comment in GCBASIC using many different methods. I'm using a /, and then this is what's called a group. So I can say /* ends with a star and a forward and a back and a /, and it sort of makes a whole block of comment. All right, let's start with the meat. I have got a chip called a 16F1937 installed. Let me just delete that for you. If I wanted to put that in, I type start chip 16F, and it gives me a list of all the chips. Look, 1937. There's two different types. There's a low voltage one, but I want that one. The frequency of the chip will always operate at the fastest frequency. and we'll look into how you can change that later on. But just assume for now that all the frequency has been set up for you. I mentioned this, option explicit. Oh, just put it in, just use it. It just says you have to define your variables, and this is sort of important because as you get into more complex programming, you need to ensure that your defined variables of a type. We're not going to be doing variables for another video, but you just need to make sure that you get into good practice. I put this little diagram in. This little diagram really is just what I'm talking to. So I can very, very quickly look at the screen, look at the program and go, okay, what have I got connected? Well, on here, it says port B, 0 to 3. These three have got LEDs attached. Hey, this isn't rocket science. You can comment this as much more, but I receive lots of source code with no documentation of what it is, and I'm supposed to work out what's going on. This is just good practice. So you can look in and go, oh, okay, that's what it is. Or you could do this. I was going to bring it up. Have I got it? Oh, or you can send this lot and have me wade through a diagram like this. Not acceptable. Just a little bit of documentation goes a long way. This is a little bit of documentation. And then we have our program. I'm setting the direction of a particular port B, through to port B.3 to out. There's an output. And then I'm saying port B.0 equals 1. That means make it work. Now, I've installed this, what's called the IDE. GC code is the actual name for this editor. I've installed PIC Plus. I know it's attached because I used PIC Plus to check it was there. If I press function key F6, it will compile my program. Look at this. And it says down here that I've compiled the program in 3.2 seconds and it's produced a hex file in 0 seconds. It's quite fast. If I want to program it and you have successfully connected PIC Plus or an alternative, and we will look at how you make alternatives later on, press function key F5, it will then do the same, but it will compile your program and then it will send it down to the chip. And if we now look at the chip, pretty hard to see, the LEDs are actually on. I wonder how, if I can actually turn up the contrast on this camera. Let me turn up the contrast on the camera. Lab camera, filters, properties. How do I change the video? Contrast, it's set to automatic. Oh, no, it didn't fix it, did it? Brightness. That is very, 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 very poor. Default that. I might go and turn the lights off. You're going to have to wait a moment. I'll turn that light off there. Is that any better? Oh, I can see them now. Yeah, now I can see them. Let's go back to our program. And what we're going to do is we're going to change these LEDs and have a few come on and a few off. So in my source program, I'm going to change. I'm going to say I'll have the second one off and the fourth one off. Function key F5. And what we're going to see that these LEDs here change. Just programming it. Very hard to see. I'm going to go and turn the lights off. One moment. I've definitely turned the lights off in the lab, haven't I? But you can see that that is actually now doing. This is the power LED. You can still see that. That's the power LED. You can see written on it. RB0, RB1 is off, RB2 is on, and RB3. And what we're going to do later on, we're going to give these, we're addressing the port directly using port B dot whatever. We will start using sort of an alias to that to make it a little bit easier. So what we've done is we've got our board running, we've got our compiler running, and we've actually done something. That is the end of this first video. Let's go back to my presentation, see what other key messages I've got for you in here. We've done the chip option explicit, DIR, and we've assigned a value to the microcontroller bit, which makes the LED come on or off, as the case may be. So next time we'll be looking at making those 4 LEDs flash in sequence. Enjoy. Thank you. Like and subscribe.